All right, so we're using the Mastery Check Review to do three things. To learn and practice compound probability, to look at tree diagrams, lists, and tables, and to look at simulations, okay? Number one, so when you're reading these problems, from this point on, you've got to ask yourself, am I doing one thing or more than one thing? One thing is simple probability, more than one thing is compound. Stephen rolled a number cube numbered 1 through 6 2 times. Well, right there, it tells me I'm doing what? He rolls it 2 times. Am I doing one thing or more than one thing?
More than one.
More than one thing. So, this 2 times right here tells me that I have compound probability. This is compound. Meaning that I'm going to have multiple events okay? I have multiple events. And I'm going to flip a coin once. So how many things am I doing? I'm rolling a number cube 2 times and flipping a coin once. How many? 3. So what I want you to do is draw you a 3-layer bridge map right there. Okay? This is event 1. This is event 2. And this is event 3. Okay? So, event 1, I'm rolling a number cube. And on event 1, I want to know what is the probability of rolling an odd number. So on event 1, I want an odd number out of all numbers. What I want over all I have, right? Event 2, I want a 5. So on event 2, I want the number 5 out of all numbers. Now, this is where doing compound probability is where you're going to see the importance of writing down what you're doing in each event before you try to determine the probability, okay? You're going to see the importance of writing down what you're doing, writing down what I want over all I have before you determine the probability. And then flipping a coin once and getting tails. So I want tails out of all sides. Okay? Anybody have any questions about how I did that?
No.
So now, an odd number. That would be a 1, a 3, or a 5 on a number cube, right? So how many numbers is that?
3.
Out of how many?
3 out of 6.
Right? And getting the number 5 out of all numbers, what is the probability of that? 1 out of 6. And getting tails is what? 1 out of 2. So I'm doing this, and this, and this. The word "and" is going to be a trigger to know you have multiple events. The word "and" is going to be your red flag for multiple events. Okay? So I'm going to take those 3 events. 3 out of 6, 1 out of 6, and 1 out of 2. Multiply them together, and I get 1 out of 24. And that is the probability of getting an odd number, the number 5, and tails. And that is compound probability. We're going to take this one step further and use it to review everything. If we change that to a decimal, we're going to get 0.04. Take that 0.04, multiply it by 100, and you get 4%, which is unlikely. I'm just throwing all of that in there as practice to make sure that we're getting everything we need in one fell swoop. Okay? I will save this and be able to put this onto Google Classroom for you to have. Number 2 is going away. Scratch it out. We're not doing it. Number 3. Eli has 2 spinners. One spinner is divided into 4 equal sections, A, B, C, D. The other spinner is divided into 6 equal sections, 1, 2, 3, 4. If Eli spins the 2 spinners at once, how many possible outcomes will include either a 1 or a 4? My husband, probability is part of the math strand called statistics and probability. And my husband, when he was in school over in Columbus, at Columbus State, he literally worked in the math lab as a statistics and probability tutor. He can do this stuff. He can look at that and tell me the probability just poof. Not me. I have to do something that's going to help me visually. And on these, with the 2 spinners, and there is one very similar to this on your test. When you have 2 spinners, in all capital letters, I want you to write, make a table. Make a table so that you can see the outcomes. Okay, so this is going to give us some practice on making a table. But this question, a very similar question like that, is on the test. When you have 2 spinners. So I've got one spinner with an A, a B, a C, and a D. That's spinner 1. Okay? I need to move that down just a little bit. This is spinner 1. This is spinner 2. And it has a 1, a 2, a 3, a 4, a 5, and a 6 on it, right? I'm changing my color for a reason. Okay? So, you read this table just like you would a multiplication table. Y'all know how to do multiplication tables. This is a two-way table. You did this with Punnett squares when you did genetics with Mr. Knight. Okay? So, right here, this would be A1, A2, A3, A4, A5, and A6. So that would be then I have B1, B2, B3, B4, B5, and B6. C1, C2, C3, C4, C5, and C6. D1, D2, D3, D4, D5, and D6. Does anybody have any questions about how I did that? Okay? Give you just a second. If you're watching on the video, this is your time to... Now, the outcomes in a table are found. The outcomes in a table are found right here. These are the outcomes. Okay? Those are your outcomes. So our total outcomes right here equals what?
23.
24. Okay? 24. Now I want to know the outcomes that have a 1 or a 4. Well, all of those have a 1. All of those have a 1. And all of those have a 4. So I have 8 outcomes with a 1 or a 4. Notice that it asks you for outcomes and not the probability. Okay? If it had asked you for the probability, I'm going to come right over here. If it had asked you for the probability, the probability of getting a 1 or a 4 would be 8 out of 24, which is 1 out of 3, which is 0.3 repeating, which is 33%. Okay? Which would be, I think we call that a small chance. All right, I'm gonna give you a minute. Huh? And here's the thing, if you don't get everything written in class today, you can always go back to the video and write it down as you watch the video, okay? That is only if it asks you for the probability. It didn't ask us for the probability, it asked us for the outcomes. This is the answer to that question. This is just, should it ask you for the probability? I'm just, like I said, I'm using this. We're kind of reviewing everything all at one time, okay? So if it had asked for the probability, that's what you would have done, okay? But it only asks you for the outcomes. Number 4. Mr. Wheelis must choose 1 pair of pants, 1 shirt, 1 tie to wear to work. His possible choice combinations are shown in the tree diagram below. If Mr. Wheelis chooses these work clothes at random, what is the probability he will choose black pants, a white shirt, and a blue tie? Well, the way you're going to do this, I'm going to start at black pants, follow my lines. I want black pants, a white shirt, and a blue tie. So there it is. There's my combination of black, white, blue. Okay? It's asking us for probability, which means we've got to do this as what I want over all I have. What do I want? I want black, white, and blue out of all the combinations. Right? I have 1 black, white, and blue combination. Right? When you have a tree diagram, to me, once you've got your tree diagram done, to me it is best to create your list. So we're going to create a list from this. I'm going to come up here and do a list, and then we'll talk about the all. Okay? Let's do our list. And we're going to start with tan. So we could have, so what are all the different combinations that I could have? All the different combinations I could have. I could have a tan, white, blue. So I could have a tan, white, blue, tan, white, red. I could have a tan, black, blue, tan, black, red, tan, blue, blue, tan, blue, red. Okay? Or I could have black, white, blue, black, white, red, black, black, blue, black, black, red, black, blue, blue, and a black, blue, red. Those are all of my combinations. What's the matter? Did you get all that? Did you see what I did? All I did was follow the lines. Tan, white, blue. I'm just using BU for blue and BL for black. just so I don't have a BB and a, you know. So this is tan, white, blue, tan, white, red, tan, black, blue, tan, black, red, tan, blue, blue, tan, blue, red, black, white, blue, black, white, red, black, black, blue, black, black, red, black, 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 blue, blue, black, blue, red. I just followed my lines. Okay? I want black, white, blue, which is right there. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
1 out of 12.
So there's a 1 out of 12 chance. And I went ahead and did that is a 0.08 decimal, an 8% unlikely. And I just did that too. But when you have a tree diagram and you're asked a question about probability, it's really good to write your combinations so that you can count them correctly. You can count right here to get your total. That number right there is also 12. Okay? That number is also 12. All right, Anthony tosses 3 dimes at the same time. If you don't get something on here, remember, if you don't get it now, you can get it. I'm going to post this key and I'm going to post the video so you'll be able to go back. Anthony tossed 3 dimes at the same time. What is the probability that 2 dimes will land on heads and the 3rd dime will land on tails? Okay? So what do we got here? I've got dime 1, dime 2, and dime 3. Okay? When I toss dime 1, I can get a heads or a tails. All right, watch me do this because this is important. Okay? That's my option. If I get heads on the first one, dime 1 gives me heads. Dime 2 could give me a heads or a tails. If I get tails, dime 2 could give me a heads or a tails. Right? Dime 3 can give me a heads or a tails. You see what's happening? So now let's write our combinations. Dime 1, dime 2, dime 3. I can get a heads, heads, heads. I can get heads, heads, tails. Look, hey, let me get my highlighter. Heads, 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 heads. Okay? Or I can get heads, heads, tails. Right? Does everybody see what I'm doing? Or I could get heads, tails, heads. Or I could get heads, tails, tails. Right? Or if I land on tails, I can get tails, heads, heads, or tails, heads, tails. It did not change until, or tails, 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 heads, or tails, tails, tails. That's all my combinations. Now the question wants to know, what is the probability that 2 dimes will land on heads and the third will land on tails. Well, I need to know which ones are, where do I see 2 heads and 1 tail? I have 2 heads and 1 tail there. 2 heads and 1 tail there. 2 heads and 1 tail there. Right? So the probability is 3 out of 8 that I will get 2 heads and 1 tail when I toss the coins. The key to this and knowing that this is the kind of probability we want to be dealing with in 7th grade is the words right there. It says they tossed them at the same time. Okay? Questions? All right, number 6. Miss Rogers is the youngest of 4 children in her family. What is the probability she has 2 brothers and 1 sister born in any order? When I looked at this tree diagram, I had to look at it for a minute. So we're removing Miss Rogers from the equation for a second. This would be the 2nd born child, 3rd born, 4th born. Okay? So if we get a brother first, so let's write our combinations. You ready? We can get brother, 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 sister, brother, sister, brother, brother, sister, 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 brother, brother, sister, brother, sister, 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 sister. Do you see what I did? And now I want to know what's probability she has 2 brothers and 1 sister. So I'm looking for 2 B's and 1 S. 2 B's and 1 S, 2 B's and 1 S, 2 B's and 1 S. 1, 2, 3, 4, 5, 6, 7. I missed one. There should be 8. Brother, 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 sisters, brother, sister, brother, brother, sister, sister, brother, sister, brother, brother, sister, brother, sister, sister, sister. Oh, I got sister, sister, brother. I missed. But there's 8. This still doesn't change that. It's 3 out of 8. You can always double check yourself to make sure you have all your combinations right here. I knew I had 2, 4, 6, 8 combinations. And I needed to know what they were. Okay? Number 7. A cook prepared sack lunches for some hikers. He had a tuna, turkey, or ham, turkey, or tuna sandwich and either banana cereal bar. What is probability that a sack selected at random will not contain a cereal bar? Well, let's do our combinations first. Ham, banana. This one's easy. Ham, cereal bar. Turkey, banana. Turkey, cereal bar. Tuna, banana. Tuna, cereal bar. There's our combinations. We don't want a cereal bar. It says in the question, will not contain a cereal bar. So I'm marking those off. And we have 3 out of 6, which is 1/2. You with me? So far, so good? Huh? It's not hard. It just takes a minute to, and again, you're going to have this to go back and watch. All right? Here's the thing, guys. These questions have a lot of words to read. And I don't want the reading, it's not, don't let all the words mess you up. Okay? Find the stuff in the question that's important and pull it out. We're skipping 8 and 9 and going to number 10. The table below shows the possible outcomes when two spinners that are divided into equal sections are spun. The first spinner is labeled with 5 colors, and the second is labeled with numbers 1 through 5.
I need like 2 erasers. The little ones that you put on like your head or something.
I don't have any on the end of the pencil. I'm sorry, I'm out. Huh?
You have like this.
That's the first spinner. That's the second spinner. And hold on just a minute and let me do this, even though I'm busy. Now, first spinner, second spinner. According to the table, what is the probability of the first spinner landing on the green and the second landing on the number 3? Well, there it is right there. There's only one. Green, then 3. Green, then 3. So that's 1 out of, and we have to count these. This is your total right here. That's your total. And it's 1 out of 25. And if you put that in the calculator, what do you get as a decimal? What?
0.04.
Because somebody kicked it.
I probably did and didn't notice. You got it wrong. 0.04. How did it on the seat like that?
All right.
I don't know.
0.04, when I multiply that on out, I get 4%, which is unlikely. Now, if y'all told me wrong on this, that's going to be on the video. Just know, they did that, I didn't. All right. Number 11. Any questions about that one? Number 11. A fair coin is flipped 2 times. Create a tree diagram. Well, here we go. You ready? Coin 1. Well, it's flipped 2 times. Sorry, that's going to be toss 1. Toss 1. I could get heads or tails. Right? Toss 2. I can get heads or tails here. Or I could get heads or tails here. That is the tree diagram. But let's write our outcomes. Let's write our combinations just so that we can practice that. We could get a heads, heads. We could get a heads, tails. We can get a tails, heads, or a tails, tails. That is all there is to it. I mean, that is tree diagrams. And, I mean, what you're doing right here with these tree diagrams is everything you need to know. Okay? We're skipping 12. We're skipping 12. And going to 13. Joshua rolls a fair number, cube number 1 to 6. Ant tosses a coin. You can go back and rewatch this if you need to. Tosses a fair. All right. So what is he doing? One event or two? More than one event? Multiple events or one? Multiple events. So this is compound probability. This is multiple events. He's doing 2 things, right? So I'm going to draw me a 2-layer bridge map. I can tell you without a doubt that on your test there are nothing more than 2 layers. Nothing with 3. Okay? Nothing with 3. So this is what I want over all I have. What do I want first? An odd number. So I want an odd number out of all numbers. And then I want heads out of all. A fair number cube is a dice. Remember that. A fair number cube is a dice. So my odd numbers are 1, 3, and 5, meaning I've got 3 odd numbers out of 6. And my coin, I've got 1 heads out of 2. I have multiple events, so I'm going to come over here and multiply. And I get 1/4. This says write an expression, so you could say anything. There's 1 out of 4 chance of him doing this. There's a 25% chance, whatever, okay?
Is the test answer choice?
Yes. Well, no, there's a few extended response. Oops, and heads. There is a 1 out of 4 chance of getting an odd number and heads. Tristan has 3 pairs of pants. Black, khaki brown, 4 shirts. He does not care which colors he wears together. If Tristan chooses 1 pair of pants and a shirt at random, what's the probability that his outfit will not be khaki pants and a red shirt? Well, before I do that, when I have something like this, I prefer a table over a tree diagram. You can do a tree diagram or a table right here. I recommend you make a table. If you only have 2 events, you can make a table. But if you have more than 2 events, you can't. You have to do a tree. So we're going to make a table right here. I have pants and I have shirts. My pants are black, khaki, and brown. My shirts are yellow, red, blue, and white. That's a blue right there. Blue. Yellow, red, blue, and white. That ran together. Fix it. Yellow, red, blue, and white. So now let's put them together. I could have black, yellow, black, red, black, blue, black, white. Khaki, yellow, khaki, red, khaki, blue, khaki, white. Brown, yellow, brown, red, brown, blue, brown, white. My combinations are inside this box. And I want to know what is the combination. Alright, so I do not want khaki pants with a red shirt. So I'm going to mark that one out. Khaki pants with a red shirt. I don't want that one. Right? So what do I have left? I had a total of 12. There are 11 left. So the probability is 11 out of 12. Okay? Number 15. She wants chips and fruit as a snack. She has a choice of either Doritos or Lay's. She can choose either apples or strawberries to complete her snack. Create a list. Well, I don't like to make a list until I make a table. We're going to make a table first. A table is the easiest way to make a list. You can make a list from, so I've got chips and fruit, right? I have Doritos or Lay's, and I have apples or strawberries. You see that? I'm trying not to get in y'all's way of seeing. Do y'all need to move? Do you need to move so you can see? Am I standing in your way? Right here, this will be a Dorito apple, Dorito strawberry, Lay's apple, Lay's strawberry. I'm just going to come over here and put Dorito apple, Dorito strawberry, Lay's apple, Lay's strawberry. There's my list. There are 4 outcomes. Number 16, the sample. All right, another thing I needed to, sample space. Sample space is your outcomes. This is sample space. All of this is your sample space. This would be your sample space. This is your sample space, okay? That's your sample space or your outcomes, okay? Those 2 words are interchangeably used. I meant the sample space S for flipping a fair coin 3 times shown below. What is the probability of not obtaining only tails? Well, it's showing you the sample space. Basically, it's made you a list. We do not want tails only. So I'm going to scratch that out. I don't want tails only. So the probability is of not obtaining only tails is 1, 2, 3, 4, 5, 6, 7 out of 8. The next 2 questions are simulations. There's a lot of words that paint a picture and give you a scenario that is good information that you need to read. But we're going to pull out what we got to know to get the answer. It ain't hard. Okay? So, here we go. So, 1 out of 6 customers who entered a store to return merchandise. The store manager designed a simulation using a random number generator to model the data for 30 customers. Simulations are mostly always done on a computer. Okay? What they determined was the digit 5. So they did a random number generator and said, these are people. Okay? These are people. And they used the numbers, I guess 1 through 5. Every time the number 5 comes up, that is a person who's returning merchandise. Okay? Every time a number 0 through 4 comes up, that is a person not returning merchandise. That represents. And they said, we're going to do this 30 times to represent 30 people and see what we get. See how many times the number 5 pops up. Okay? They want to know, so here's the results. They did the number generator the first time, got a 0. Did it again, got a 4. Did it again, got a 0. Did it again, got a 0. Did it again, got a 5. Did it again, got a 5. And they kept doing it until they did it 30 times. Okay? Here's our question. Based on the simulation data, out of 150 customers who entered the store, what number of customers would expect to return merchandise? Well, first, we have to determine how many customers returned merchandise in our simulation. In our simulation of 30 people, how many of them returned merchandise?
9.
And the way we do that is by determining how many number 5s we have. Because so I'm going to circle my 5s. How many 5s do you see? 9. So 9 out of 30 people returned merchandise based on our simulation. That is our experimental data. Okay? That is our experimental probability. All right? Now we're going to make a prediction. If 9 out of 30, then how many out of 150? Now I can predict for the store by how many people we think going to bring stuff back. Cross multiply starting with x, and we get 30x equals 1,350, because I've already done this. Divide both sides by 30. And x is going to be 45. So I can predict that 45 people out of 150 people will return merchandise based on our random number, based on our simulation. Okay? That is simulation. I can tell you the problem that's on your test is not this difficult, but this is a great simulation question. A simulation is just generating data to help you determine something or to help you make a prediction. Okay? All right? Miss Gully wants to randomly select 3 students for a committee. She uses 3 coins to conduct a simulation to predict the probability that the committee will have at least 2 boys. The results of 16 trials of the simulation are shown below. So Miss Gully said, okay, I've got 3 coins. I'm going to toss them and see how many times, I want at least 2 boys. She did this 16 times. So the first time she tossed it, she got tails, tails, heads. The second time she got heads, tails, tails. So she's just throwing it up, recording it. She did it 16 times, okay? She said, okay, H is going to be my girls, T's are going to be my boys. All right? And I want to know how many times I got 2 T's. Because that's going to represent my 2 boys. So we're going to go here and find our 2 T's. Oh, back up. I missed a word. Can it be 3 boys?
7.
Can it be 3 boys?
Yes.
Uh-huh.
7.
It said at least 2 boys. So, we could have 3 boys. I missed that when I did this the first time. So we got 1, 2, 3, 4, 5, 6, 7
7 out of 6.
out of 16. That is the probability. What is 7 out of 16 as a decimal?
0.4375. So if you round it,
0.4375. So 0.44, which would be 44%. We would give that a what?
Oh, we'll give that as not
Unlikely.
I wouldn't say unlikely.
As.
Maybe small chance?
Yes,
Small chance. As of this very moment in time, you've done it all. As of this moment in time, you have now been taught everything that's going to be on your test. Okay? We have one question left to go. 2 questions. But you've been taught everything that's going to be on your test. Look at number. Trinity's playing a game with 2 different types of geometric objects. One object has 8 faces numbered 1 to 8. The other has faces labeled M, N, O, P, Q, R. What is the probability of rolling a number less than 3 and bing, 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 bing. And circle that. And the letter M. So, say it. Compound. This is compound probability, which means I have multiple events. Which means I've got to have a 2-leg bridge. What do I want first? I want a number less than 3, which would be a 1 or a 2 out of all numbers. And then I want the letter M out of all letters. Right? So this is 2 out of 8 because there are 8 letters. And this is 1 out of 6. I'm going to take that 2 out of 8 and that 1 out of 6 and multiply them together, and I'm going to get 1 out of 24. All right? Everybody got that? I want to back up a minute. We videoed all this case, so you will be able to watch it and get it, okay? All right, let's scroll back down. I want to show you something right here. Total number of outcomes. In the total outcomes. I'm talking total outcomes here in this table, okay? Total outcomes in this table. We can count all of those things that are green, can't we? Can't we? Or I can take this right here, which is 6, and this right here, which is 4, and multiply it together and get 24. Okay? I'm going to show you something. Look. Here we go. Total outcomes. I want to know, over here, we're going to look at total outcomes for a minute. Number 7. If all it's asking me for is the total number of outcomes, or the total number of combinations, how many total combinations we can have. What is the sample space size? Okay? Turkey, ham, or tuna sandwich. That's 3, right? Banana or cereal bar. That's 2, right? What's 3 times 2?
6.
That's only if you're asked for the total number of outcomes, the total of the sample space, or the total combinations. The total, okay? That's only it's asking you for the total. Did I skip a whole page? No, we skipped 8 and 9. We skipped 8 and 9. Let's mark them out. Skipped 8. Skipped 9. Skip 12. All right, here's another one. If I want to just know the total outcomes. If I just want to know, this is number 14. The total outcomes. If I want to just know the total combinations. If I want to know the sample space. I have 3 pair of pants. I have 4 shirts. My total outcomes is 12. Now look at the last one on this paper. Now go to the end. Number 20. Number 20 is asking how many possible combinations. It just wants the combinations. Now you can draw a tree map and count them. You can make a table and count them. But if it's only asking you for the number of combinations, the number of outcomes, the size of the sample space, you can come right here and do what I did on my paper. Banana bread or pumpkin bread is 2. Plain or whipped, plain topping or vanilla pudding is 2. No, that's 3. Plain, whipped, or vanilla pudding, that's 3. Plain whipped or vanilla pudding is 3. You got plain whipped or vanilla pudding and pumpkin. You've got banana bread or pumpkin bread. Let me erase that and go back and do it one more time so you can see what I'm talking about. All right, ready? You've got banana bread or pumpkin bread. That's 2. 2 breads. Okay? You've got plain, whipped, or vanilla pudding. That's 3. So my possible combinations is 2 times 3, 6. That's how many combinations I would have. Now, that doesn't tell me what the combinations are. It only tells me how many. But it doesn't tell me what they are. Okay? But it tells me how many. All right? I'm going to give you